Transportation Stormwater Permit Compendium. My name is Colby Richardson with the Eastern Research Group, and I will be helping to support today's webinar. With me today are our speaker, Heather Goss, who serves as the U.S. Environmental Protection Agency's Transportation Liaison to the Federal Highway Administration. We also have Rachel Urban of the U.S. EPA and Susan Jones of the Federal Highway Administration. Rachel was one of the key people who assembled the compendium and is here with us to answer questions. Next slide, please. So before we get started, I just want to review a few housekeeping items. Today's presentation is being recorded and will be made available via the EPA's Green Infrastructure Webcast Series website. All attendees have been muted to minimize background noise. If you need to enlarge the slides, press the icon with the 4 outward pointing arrows on the top right of your slides. If you have a question during the webinar, please type it into the questions box on the upper right-hand side of your screen. We will have a dedicated time to answer questions at the end of the webinar. And if you're able, please try and direct your question to a specific presenter. Lastly, if you're experiencing any technical difficulties, please contact us via the questions box and we'll try to troubleshoot the issues. And now I'd like to turn it over to Heather Goss, the U.S. Environmental Protection Agency's Transportation Liaison to the Federal Highway Administration. Thanks for joining us, Heather.
Hello, thank you for the introduction, Colby. My name is Heather Goss, and I'm really happy to be with you here today. Susan Jones and Rachel Urban are with us as well to help field questions as a panel at the end of the presentation. This presentation is being hosted through EPA's Green Infrastructure Webcast Series. The series explores various aspects of green infrastructure, connects stakeholders, and showcases where and how green infrastructure is being used across the country. While today's topic isn't exclusively about green infrastructure, we will be highlighting ways that green infrastructure can be incorporated into transportation MS4 permits. Our goals in today's webinar are first, to share background information on stormwater from roadway environments and how transportation municipal separate storm sewer systems, or MS4s, which are considered non-traditional MS4s, may differ from traditional MS4s. I'll use the term transportation MS4 to refer to those regulated MS4s that are more linear in nature and owned or operated by departments of transportation, or DOTs. The second goal is to highlight components of MS4 permits that may be tailored for transportation MS4s and provide examples of different approaches compiled in the U.S. EPA's Transportation Stormwater Permit Compendium. I'll note that you can see a clickable link in this, to this document in the slide, but since it's a webinar, you can't actually click it on the screen. If you'd like to open the document up while you're watching this webinar, you can do a web search for EPA Transportation Stormwater Permit Compendium. The first several search results that come up from that will get you to a PDF of the document, which is one in a series of MS4 permit compendia that EPA has produced. This particular compendium presents examples of different permitting approaches that the EPA found in a nationwide review of the National Pollutant Discharge Elimination System, or NPDES, permits that specifically address Departments of Transportation, or DOT, Municipal Separate Storm Sewer Systems, MS4s. To develop this compendium, EPA reviewed individual and general MS4 final permits issued to DOTs through September 2016. The compendium also includes examples from MS4 permits that may not be specific to DOTs, but address activities DOT systems typically encounter. For example, storage and management of de-icing materials. Our third goal today is to offer an opportunity for questions at the end of the presentation. Before we get into the substance of the presentation, I want to note that the compendium we're talking about today serves as a snapshot of permit provisions that are provided as examples for others to see how transportation MS4 stormwater discharges have been addressed in existing permits. The specific example provisions are not being presented as the only ways to address a given topic in MS4 permits. The information in the compendium could be useful to NPDES permit writers both at the federal and state level who are looking for examples of MS4 provisions when they're writing or reissuing MS4s to DOTs. The information is also relevant for state DOTs with stormwater discharges covered under Phase I or Phase II MS4 permits. For DOTs, it is useful to be familiar with what kind of transportation MS4 focused permit language can be included in these permits. This compendium provides examples of the types of provisions included in MS4 permits. where other non-state DOTs, such as those at the municipal, county, district, or other jurisdiction level, are permittees or co-permittees for transportation MS4s, they can also benefit from seeing these examples. Today we're talking about EPA's compendium of excerpted permit language from MS4 permits that can be used or tailored for transportation-specific MS4 permits. So the first thing we need to do to make sure we're all on the same page is to answer, what is an MS4? I'm pretty confident that if you're joining today's webinar, you're already familiar with the National Pollutant Discharge Elimination System, or NPDES program. This program was set up under the Clean Water Act Authority and provides a structure for permitting activities that would discharge pollutants from point sources into waters of the United States. I won't get into all the nuances of the NPDES program here today, so let's just focus in and look at regulated, permitted MS4 discharges, which are one type of discharge covered under NPDES. A municipal separate storm sewer system, or MS4, is a conveyance or system of conveyances that is owned by a public entity, state, town, etc., that discharges to waters of the U.S. and is designed or used to collect or convey stormwater, for example, through storm drains or ditches. An MS4 is not a combined sewer and is not part of a sewage treatment plant or publicly owned treatment works. It helps to know a little bit about how MS4 stormwater discharges are regulated. In 1990, the Phase I Stormwater Regulation was published. It requires medium and large cities or certain counties with populations of 100,000 or more to obtain NPDES permit coverage for their stormwater discharges. The 1999 Phase II Stormwater Regulation requires small MS4s in census-defined urbanized areas, as well as MS4s designated by the permitting authority, to obtain NPDES permit coverage for their stormwater discharges. This includes non-traditional MS4s, such as Departments of Transportation, or DOTs. Most Phase II MS4s are covered under general permits, with some exceptions where individual permits have been used for Phase II and non-traditional MS4 permittees, including DOTs. Phase II MS4 permits include terms and conditions that address what are known as 6 minimum control measures, or MCMs. The MCMs include measures such as construction site stormwater management and good housekeeping. Phase II permits also address annual reporting requirements and other requirements as appropriate for the protection of water quality. You may be wondering which entities actually hold transportation MS4 permits and under what part of the MS4 regulation are they permitted. Well, it varies. Some stormwater discharges from roadways, including all of those within defined urbanized areas, are covered under NPDES MS4 regulations. Departments of Transportation may be co-permittees with Phase I MS4s under Phase I permit, and DOTs may be small MS4s, as defined by regulation, under either an individual or general Phase II MS4 permit. I also want to point out that while most regulated stormwater discharges from roads are within U.S. Census Bureau defined urbanized areas, some permitting authorities have chosen to extend NPDES permit requirements to include stormwater discharges from state and locally owned roads outside of these areas. Before we get into more information about MS4 permitting, let's talk about pollutants typically found in stormwater discharges from highways. Highways are viaducts for stormwater, and stormwater discharges from roadways contain pollutants that can impact water quality. The primary pollutants of concern in roadway stormwater include, but are not limited to, the ones you can see on this slide. The types of stormwater pollutants and their corresponding concentrations contained in discharges from roadway surfaces vary depending on the road size, the amount and type of traffic on the road and location, the type and frequency of de-icing practices, if applicable, and the type and frequency of chemicals used to manage roadside vegetation. The table here shows the median pollutant concentrations in discharges from highways, with the pollutant in the left-hand column. The middle column shows site median pollutant concentration from urban highways, and the right column shows the same but from rural highways. So you can see that roads with higher daily traffic volume have higher concentrations of these pollutants in stormwater discharges. Transportation system activities can concentrate pollutants on roadway surfaces in and around maintenance yards, park and rides, rest stops, and other areas as well. Stormwater pollutants come from construction activities, motor vehicles, including vehicle exhaust and water that splashes vehicle undercarriages, pavement wear, and roadway and right-of-way maintenance activities. The pavement itself can also increase the stormwater's temperature, volume, and velocity. Here you can see common constituents of stormwater discharge from roadways in the left column, with some of their primary sources listed to the right. For example, chloride in roadway stormwater discharges is primarily from de-icing salts. In contrast, copper in roadway discharges is primarily from cars, like bearing wear and brake lining wear, fungicides and insecticides. Today's webinar is focused on how NPDES permit terms can reduce pollutants from roadways entering our nation's waters, but I also want to point out that source control measures can also be a powerful way to reduce pollution. Copper is a good example. In 2015, the U.S. EPA, Environmental Council of the States, and 8 industry groups signed a memorandum of understanding to reduce the use of copper and other materials in motor vehicle brake pads. The agreement calls for reducing copper in brake pads to less than 5% by weight in 2021 and 0.5% by 2025. In addition to copper, this voluntary initiative reduces mercury, lead, cadmium, asbestiform fibers, and chromium-6 salts in motor vehicle brake pads. This source control initiative will decrease discharge of these materials from roads into our nation's waters. The focus for state DOT stormwater management can differ from traditional MS4 stormwater programs in several ways. Facility locations and limitations. Roadways often cross multiple watersheds and city and county jurisdictional boundaries. Therefore, state DOTs are often covered by multiple NPDES permits or are co-permittees, resulting in stormwater management solutions over a large geographic area, depending on the location of the system. In addition, linear systems often involve limitations of right-of-way space. Pollutant sources and characterization. State DOTs do not typically oversee new development, redevelopment, and construction projects outside their rights-of-way. Stormwater discharge from roadways has been fairly well characterized, and typical pollutants are known. Mission. Most state DOTs have different missions than those of traditional municipalities. They are primarily tasked with the safe transport of the public and of goods. Transportation facilities are also unique because their primary objective is ensuring the safety of the public. Therefore, the placement of stormwater controls is limited by state and federal safety requirements. Authorities. State DOTs do not have the authority to control stormwater via regulations and ordinances. Instead, they must include requirements in their agreements and contracts and establish internal policies and guidelines and cooperative agreements. Some state DOTs also issue right-of-way permits to adjacent land users to allow them to control access to their rights-of-way. Populations and communities. The communities that linear facilities reach are typically members of what we might call the traveling public. Education campaigns and outreach might be tailored to those populations specifically. And finally, inspections and enforcement. State DOTs do not typically oversee projects or facilities beyond those that they own. Now that we've talked about how stormwater discharges from roads are regulated and some of the typical pollutants and transportation-related pollutant sources you would expect, let's briefly explore typical conditions included in MS4 permits. Permits typically require regulated MS4 owners or operators to develop, implement, and enforce a stormwater management program, or SWIMP, related to the following conditions. Construction. MS4 owners and operators are required to include a program in the SWIMP to reduce pollutants in stormwater from construction activities that disturb 1 acre or greater of land. Illicit discharge detection and elimination. Stormwater and certain authorized types of uncontaminated non-stormwater are the only discharges that should enter the MS4. Illegal dumping and connections can result in illicit discharges of non-stormwater waste, like car oil and sanitary waste, into it. Owners and operators include a program in their SWIMP to detect and eliminate illicit discharges to their systems. Pollution prevention and good housekeeping. Minimizing the potential pathways for contaminants carried in stormwater is a key way to control pollutant discharges from MS4s. It's important to include a program to prevent or reduce pollutants from municipal operations into the storm sewer system. Post-construction. Managing stormwater after construction activities end is a key part of the SWIMP. The SWIMP includes a plan to reduce pollutants from new development and redevelopment projects that disturb 1 acre or more of land. Public education and outreach. An informed and knowledgeable community is crucial to the success of the SWIMP. An owner or operator implements a public education program on the impacts of stormwater that includes steps to reduce pollutants in stormwater. Public involvement and participation. The public can provide valuable input and assistance in developing, implementing, updating, and reviewing the SWIMP. Owners and operators should include efforts to reach out and engage all economic and ethnic groups in their public participation program. Some of you are likely familiar with the first 6 bullet points here, which are commonly referred to as 6 minimum control measures. In addition, MS4 permits typically include requirements related to program effectiveness. That means owners and operators evaluate the program's effectiveness and make adjustments as necessary. And requirements related to total maximum daily loads, or TMDLs. It's important to identify how to address discharges to an impaired water body or a water body with an approved total maximum daily load, TMDL, where relevant. A little later in this presentation, I'll be talking about some examples of how transportation MS4 permit terms can address many of these different categories. For the next 3 slides, I'm going to include some background information on roads and highways to familiarize you with some basic background terminology related to the roadways themselves. The information is meant to familiarize permit writers with terminology that may help you understand and communicate with transportation permittees. These slides are excerpted from the Compendium, which contains boxes of background information and discussion throughout. This is a diagram of the Federal Highway Administration's functional classification of roads. It groups streets and highways into classes or systems according to the type of traffic service they provide. Roads can be either rural or urban and then are divided further. Local roads serve homes, businesses, farms, and small communities and provide access to collector roadways. Collectors channel traffic from local roads to the arterials, which allow people to travel between larger towns and major cities. Transportation agencies often use miles as a unit of measurement to estimate the length of a section of road. They use lane miles, which take into account the number of lanes that are present in the same section of road. A stretch of highway 1 mile in length with 4 lanes equates to 4 lane miles, as seen in this diagram. Each state permitting authority may classify new development, redevelopment, and roadway repair and improvement activities differently. DOTs typically classify their activities into new construction, reconstruction, rehabilitation, resurfacing, restoration, and maintenance. Because of these differences that can occur, we've seen it's very helpful when state permitting authorities and the transportation agencies work together to make sure they are talking the same language. On the bottom left, you see an example of road resurfacing that does not disturb the subsurface. On the right, you see an example of routine maintenance, such as filling in potholes. Other routine maintenance can include repainting lane and edge lines, removing accumulated debris from drainage inlets, and mowing. Transportation agencies often incorporate stormwater facility maintenance into larger asset management and operations and maintenance programs, or, in some cases, track and execute a standalone stormwater facility maintenance program. Stormwater facilities include, but are not limited to, catch basins, detention basins, filter strips, riparian buffers, infiltration trenches, sand filters, constructed wetlands, wet ponds, bioretention systems, low-flow bypasses, and stormwater conveyances. Now that we've discussed some background information on MS4s, roadway pollutants, and DOT activities, let's move into the actual compendium of MS4 permit terms. First, we'll talk about the organization of the compendium. As you can see on this page, we've organized the examples provided in the compendium according to the types of activities or locations that transportation departments typically encounter. When I move on from this slide, we'll walk through some of the different topic areas. We won't be covering every single topic area in the compendium or every single topic area in an MS4 permit. We've just chosen a range of areas to give you a sense for the breadth that the compendium covers. We'll talk about what's notable about each topic in terms of what might be specific to transportation MS4s as opposed to other MS4s for that topic. We'll also talk about how transportation MS4 permit language could address the topic based on some examples from the compendium, though we won't show example permit language for each topic. You'll have to look that up in the compendium itself. One topic the compendium addresses is establishment of the Stormwater Management Program, or SWIMP. Here we'll talk about several subtopics of SWIMPs, such as the first one here, legal authority. An overarching legal authority framework must be established in order for an MS4 permit swim to be effective. Permittees must have the authority to carry out all aspects of their stormwater management programs, including requiring the control of pollutants flowing into the MS4 system, having access to inspect sources of pollutant discharges, and being able to compel compliance and issue citations in the event of violations. This legal authority is typically established through the adoption of one or more ordinances or by modifying existing ordinances to provide the necessary authority. In the case of a transportation MS4 permit, the scope of legal authority available to a DOT often differs from that available to a municipality. DOTs often cannot pass ordinances, nor do they have enforcement authority like a typical municipality. Legal authority may consist of policies, standards, or specific contract language. Non-traditional MS4 permittees also do not generally have the authority to impose a monetary penalty, so they should utilize other mechanisms and authorities that they do possess. The Compendium has example permit language excerpts that include acknowledging the DOT does not have ordinance authority and therefore would need to use other mechanisms like developing policies or procedures to address permit requirements in the absence of ordinances, and establishing agreements with other agencies for enforcement where the DOT lacks authority. For example, some DOTs have agreements with their state police departments to assist with enforcement that they may not otherwise be able to do. The Compendium also includes permit examples related to sharing responsibilities. The stormwater regulations allow that the permittee may rely on another entity to satisfy its NPDES permit obligations to implement a minimum control measure, and that EPA encourages the permittee to enter into a legally binding agreement with that entity if the permittee wants to minimize any uncertainty about compliance with the permit. As discussed on the previous slide, DOTs often have different legal authorities and may need to rely on other entities to satisfy permit obligations. Permit language around shared responsibilities may address points such as specifying that relying on another entity is allowable, requiring commitments in writing, or requiring formal interjurisdictional agreements among permittees that choose to share SWIMP implementation responsibilities. For example, a permit could specify that the agreement must address roles and responsibilities for each permittee, monitoring responsibilities, reporting responsibilities, financial arrangements between permittees, and communication and coordination. The Compendium provides permit examples related to enforcement as well. Due to the linear nature of a road system, DOTs may need different strategies than municipalities for ensuring compliance with stormwater requirements. For example, a DOT may encounter permit non-compliance from a construction site or construction operator, or illicit discharges originating within another regulated MS4. DOTs may use encroachment permits and, as mentioned earlier, may utilize the State Highway Patrol or police to deal with major stormwater issues. There are examples of permit language in the Compendium that specify the DOT's responsibility related to contractual requirements and removal of temporary sediment control BMPs, or best management practices, and that specify the process the DOT must use to notify the permitting authority, generally that's the state environmental agency, of permit noncompliance. An important aspect of the SWIMP is interaction with the public. In fact, 2 of the 6 minimum control measures for Phase II MS4 permits are about interfacing with the public. One is public education and outreach, and the other is public involvement and participation. It's critical for MS4 permittees to include education and public involvement in the SWIMP. An informed and knowledgeable community will help engender greater support for and compliance with the program. There's flexibility in how these things can be addressed, so a DOT permittee may target outreach and education specifically to the traveling public. While a typical MS4 might focus on educational programs for school-age children or hiking trail signage on tributaries for hikers, a transportation MS4 might instead include targeted outreach to their traveling public in places that would reach them, such as outreach to pet owners at rest stops. Permit language around public education and involvement could include provisions specifying that a DOT permittee may target outreach and education specifically to the traveling public, specifically identifying who the public is for the DOT, or listing specific target audiences to consider among the traveling public, for example, truckers, pet owners, garbage haulers, when they're developing outreach. Total maximum daily loads, or TMDLs, for impaired waters pose unique challenges to DOTs. A TMDL is a calculation of the maximum amount of a pollutant allowed to enter a water body so that the water body will meet and continue to meet water quality standards for that particular pollutant. A TMDL determines a pollutant reduction target and allocates load reductions necessary to the sources of the pollutant. For waters that have been listed as impaired and are subject to a TMDL, SWIMPs must address TMDL requirements. DOTs are actually subject to TMDLs in every state of the U.S., so it's not uncommon. Among the challenges are that transportation MS4s discharge in multiple TMDL watersheds, the pollutants are varied, highways have a large number of outfalls, and DOTs have limited authority to control sources, for example, pollutants that come from vehicles. There are multiple examples for how transportation MS4 permits have addressed TMDL requirements. For example, the Compendium has excerpts of permit language specifying impaired water bodies, pollutants of concern, and associated waste load allocations in the TMDL itself. There's also excerpts of permit language requiring a GIS layer for urbanized and impervious areas within the coverage area of the permit. And also permit language that has specific requirements, for example, monitoring and schedule for meeting requirements to show consistency with the TMDL or TMDLs. As a side note, I want to point out that there are some additional resources available to MS4 permit raters that may be of particular use in situations where waters are subject to TMDLs. One is another document in the series of EPA's Compendia of MS4 permitting approaches that focuses on water quality-based requirements. And another is a National Cooperative Highway Research Program, or NCHRP, report called Approaches for Determining and Complying with TMDL Requirements Related to Roadway Stormwater Runoff. I'll include links to those resources at the end of the presentation. Highway agencies spend more than $2 billion every year on winter maintenance. These operations often involve de-icing techniques and/or anti-icing techniques that use a variety of chemicals, such as salts, to prevent ice and snow from forming on roads or to remove it. Chloride-based salts are the most commonly used material for snow and ice control, followed by acetates. In 2015, nearly 32 million tons of salt were used for highway de-icing in the United States. That's 46% of 69.5 million tons consumed total. Studies have shown an upward trend in freshwater chlorides, which is thought to be the result of de-icing salt applied to roadways, parking lots, driveways, and sidewalks. The facilities where DOTs store these materials can also be sources of pollutants. For example, most de-icer abrasives are stored outside and are not covered. Uncovered salt piles can contribute significant pollutant loads to surface and groundwater. Transportation MS4 permit language about winter maintenance can address points such as requiring characterization of de-icers used and documentation of application data, not authorizing direct discharge of snow disposal into receiving waters, or specifying proper storage of de-icing and anti-icing materials. DOTs often have facilities other than roads that are covered by the MS4 permit. For example, parking lots, rest areas, and maintenance yards. Stormwater management considerations at these facilities may be different than those for linear roadways. Unlike municipalities, DOTs may lack the mechanism to incorporate pollution prevention and good housekeeping requirements into ordinances. MS4 permit language can address those sorts of requirements. For example, it can require inventory of specific facilities, such as maintenance yard facilities, and related potential pollutant sources. It can describe facilities management best management practices, or BMPs. It can require developing standard operating procedures, or SOPs, for spill prevention and response. And MS4 permit language can require facility inspections to ensure indoor drains are sealed or go to sanitary sewers. DOTs often have hundreds or even thousands of catch basins, outfalls, inlets, and best management practices, or BMPs, to track, operate, and maintain. Maintaining everything, everywhere, on identical schedules may prove challenging. Therefore, many DOTs find it helpful to develop maintenance requirements that systematically prioritize schedules and inspections based on water quality and other criteria. The Compendium has an example of permit language that specifies catch basin inspection and cleaning frequencies. This particular example specifies different schedules and numbers of catch basins that must be cleaned depending upon the number of catch basins that the highway agency operates. Permits can also address maintenance frequencies and schedules for other components of the stormwater system as well. This is just one specific example in the Compendium related to catch basins. DOTs are responsible for managing roadside vegetation for safety, for example, maintaining view of approaching vehicles and hazards, also for stormwater drainage, supporting pollinator habitat, managing invasive species, supporting aesthetics, and other reasons. DOTs need to make decisions regarding management, including mowing and using herbicides to manage invasive species and noxious weeds. MS4 permits can include terms that will support the DOT's management of roadside vegetation while also protecting water quality. Permit language on vegetation management and transportation MS4 permits could include provisions establishing a minimum standard for herbicide application, requiring collection and disposal of unused vegetation management chemicals, requiring DOT contractors using herbicides be trained and certified, and specifying consultation with vegetation management experts, such as state university extension programs. For example, one permit in the Compendium calls for consultation with the state's Department of Agriculture and Consumer Services and the state university in selecting appropriate pest control methods and implementation practices. DOTs often require encroachment permits to allow certain construction, installation, and repair-related activities within, under, or over a state right-of-way. When available, DOTs may use encroachment permits to ensure that third parties act consistent with MS4 permit requirements. Examples of permit language addressing this topic in the Compendium include excerpts that require the permittee to educate industrial facility owners and operators about impacts to the storm sewer system, require the permittee to inspect encroachment permit construction projects, and require the permittee to control third-party activities within the right-of-way. The last few topics we'll mention today relate to project development. Let's talk about developing and planning highway projects in terms of stormwater management. Whether it's new construction, reconstruction, rehabilitation, or maintenance, highway improvement projects can potentially release various pollutants when it rains or snow melts. Anyone who's seen a construction site in the rain can understand the importance of good practices to manage stormwater pollution when so much soil is exposed. DOTs often use advanced planning to determine ways to reduce discharges of these pollutants in stormwater and snowmelt during both active construction and post-construction, and they will also implement structural and non-structural practices to manage stormwater. The Compendium has an example of permit language addressing the stage of active construction and contaminated soils. The permit required the DOT to notify the permitting authority if it will be using lead-contaminated soil that qualifies as a hazardous waste under the state definition, and to comply with the terms of the variance that allows limited use of such soil. After the active construction period ends, post-construction stormwater controls are important to reduce discharges of pollutants in stormwater and snowmelt. Phase I MS4s SWIMPs must address controls to reduce pollutants in stormwater discharges after construction is completed on new and significant redevelopment. The Phase II regulations require regulated small MS4 operators to develop, implement, and enforce a program to address stormwater discharges from new development and redevelopment sites that disturb greater than or equal to 1 acre of the MS4. The regulations also require that the MS4 ensure that control measures are installed and implemented that prevent or minimize water quality impacts. Permit language for post-construction stormwater controls in transportation MS4s includes identifying specific standards that apply to development and redevelopment, and including links for easy access, performance standards for post-construction controls, including specific thresholds based on imperviousness and disturbed area, requiring development of a best management practice, or BMP, toolbox, or prioritizing specific types of BMPs, or green infrastructure. And I'm going to get a little bit more into green infrastructure in the next few slides. A couple more remarks here on post-construction before I talk more about green infrastructure. The first is regarding terminology. Post-construction, in the context of an MS4 permit, specifically means post-construction stormwater control measures. However, some DOTs have indicated that maintenance crews may automatically affiliate the term post-construction activities with activities like mowing grass, simply because they also happen post-construction of the facility. It may be helpful to clearly define whatever terms are used so that the terminology is not lost in translation with the people actually implementing the post-construction stormwater control measures. I also wanted to mention that the American Association of State Highway Transportation Officials, or AASHTO, Center for Environmental Excellence, summarized input from a national meeting of DOT stormwater practitioners that discussed approaches to incorporate post-construction BMPs in the project delivery process. They recommended a few practices to help meet permit compliance and protect infrastructure. These included assigning a lead management position to oversee and ensure communication between workers and management during each phase of the project delivery process, involving maintenance personnel early on in the design process and justifying the use of certain BMPs, and incorporating state-specific standards and highlights into proposed contracts. One thing to think about when planning for post-construction stormwater controls is the opportunities that roadway projects have to incorporate green infrastructure. So what exactly is green infrastructure, and what's the difference between green and gray infrastructure? The answer to that question is a matter of intent and function. Gray infrastructure is designed to move stormwater away from the built environment. For example, conventional piped drainage and water treatment systems. By contrast, green infrastructure uses plants, soils, and other media to capture, treat, and evapotranspire stormwater at its source. The term green infrastructure encompasses a wide variety of practices that function across multiple scales, and as you can see on the slide, is specifically defined in the Clean Water Act in Section 502. Green infrastructure elements in highway projects could include vegetated filter strips, vegetated swales, fire retention, permeable pavements, or others depending on the site characteristics. The common element among all these practices is that they manage stormwater where it falls instead of conveying it somewhere else. Green infrastructure is a cost-effective, resilient approach to managing wet weather impacts that provides many community benefits. Green infrastructure reduces and treats stormwater at its source while also delivering environmental, social, and economic benefits. It uses vegetation, soils, and other elements and practices to restore some of the natural practices required to manage water and create healthier urban environments. In case this sounds really familiar but you don't recognize the term green infrastructure, I should mention here that different entities call green infrastructure by other names. For example, low impact development, or LID, or green stormwater infrastructure, or GSI. Transportation projects may present many opportunities to incorporate green infrastructure to meet post-construction stormwater management requirements, while also delivering multiple social and economic benefits. Transportation-related land uses represent an especially high percentage of overall impervious surface area within urban and suburban areas. Within the urban environment, roads, driveways, sidewalks, and parking lots can constitute up to 70% of the impervious surface area. Transportation projects in these areas can incorporate green streets, that is, streets designed to incorporate a variety of green infrastructure practices to manage stormwater on site where precipitation falls. Green streets can provide many benefits. In addition to the stormwater discharge reduction and water quality improvement benefits, which are of course the main goals of the MS4 stormwater permit requirements, green streets can be designed to calm traffic, provide safer pedestrian and bicycle paths, mitigate urban heat island effects, improve community aesthetics, promote a sense of place, and stimulate community investments. These enhancements can help to make a green and complete street that is safe and accessible for all users, while also being friendlier to the environment and beneficial for the community at large. There are several examples in the compendium of how Transportation MS4 permit language could incorporate green infrastructure elements. Permit language in Transportation MS4s could require consideration of green infrastructure during the design phase for new and redevelopment sites. Permit language could also require incentivization of green infrastructure. For example, one permit in the compendium requires the permittee to develop a strategy to incentivize green infrastructure for public and private sector projects. Permittees must begin implementing green infrastructure pilot projects within 2 years of the permit effective date, and the monitoring and reporting must include calculated or modeled changes in runoff quantities for the project sites. Since publication of the Transportation MS4 Compendium, EPA has continued to take a look at MS4 permits from around the country with an eye to terms that could be shared in the future as informational materials to state permitting authorities charged with developing MS4 permits. We have seen that MS4 permits around the country incorporate green infrastructure into post-construction requirements in numerous ways. Many permits require permittees to establish regulatory mechanisms, like codes, ordinances, and laws, to require the use of green infrastructure. Now, of course, as we had discussed earlier, permittees that are DOTs may have different legal authority and not be able to establish such mechanisms. However, there are other ways to encourage the use of green infrastructure. For example, some permits require permittees to assess current regulatory mechanisms and identify implementation barriers and opportunities for improvement. Some permits also include requirements to implement green infrastructure practices and conduct inspections and maintenance on those practices. Some require permittees to develop and/or implement post-construction performance standards and green infrastructure plans. Another thing to consider during project development is that MS4 permits or other local or state stormwater management goals often have flexibilities to meet post-construction stormwater standards that account for site-specific conditions and other factors. One such flexibility is called off-site stormwater management. A note on vocabulary here, this concept is sometimes referred to as off-site mitigation, off-site crediting, or watershed-based planning. When roadway projects make improvements to reduce water quality impacts, the improvements most often occur within rights-of-way along existing alignments. Opportunities to limit stormwater impacts can be challenging, as land within the existing right-of-way is not always available or practicable for the construction of structural post-construction stormwater controls. For example, a project site may be steep or rocky, or maybe a bridge. Redevelopment projects in dense urban areas may also face space constraints and constraints due to the existing placement of utilities. In addition, stormwater management practices installed years ago in the right-of-way may not have been designed to adequately meet more recent water quality requirements included in NPDES permits, TMDLs, or effluent limitations. In these and other scenarios, on-site stormwater management practices may be too impractical or costly to instate. Off-site stormwater management is when project developers can meet performance standards for management of post-construction stormwater, for example, volume retention requirements, at a location other than the project site under certain conditions. For example, outside the right-of-way of an infrastructure project at another location in the community or in the same watershed, instead of on-site. In some cases, off-site management may be more efficient and cost-effective than on-site management and can help achieve multiple benefits, such as additional environmental and planning goals. Another potential benefit to point out is that various communities have found that off-site management programs provide opportunities to implement green infrastructure to manage stormwater in areas not currently undergoing redevelopment, which can have environmental and community benefits. Some transportation project developers have chosen to fund off-site restoration projects such as stream or wetland restoration to help meet post-construction stormwater requirements related to water quality, such as sediment or phosphorus loadings. Transportation MS4 permit language could specifically allow for construction of post-construction stormwater controls elsewhere in the permit area rather than only in conjunction with the development project. The permit language could then point to specific information related to the relevant DOT or state environmental agency's program if they have an established structure or program for off-site stormwater management. The last topic from the compendium that we'll touch on today is monitoring and evaluation. Assessing the effectiveness of the stormwater management program allows the MS4 permittee to track progress in complying with permit provisions and identify which parts of the program need to be modified to protect or improve water quality. There are different monitoring and evaluation requirements depending on the type of permit. Phase I MS4s are required to develop a monitoring program, characterize the discharge, do field screening, and to assess their controls. Phase II permits may also include monitoring. For MS4s that contain monitoring requirements, each monitoring program is unique and should be customized to specific pollutant sources of the MS4 and the receiving waters. In the case of transportation MS4s, the program should be tailored specific to the pollutants and pollutant sources that are most pertinent to the roadway context, like we saw in earlier slides. For example, considering the chloride from de-icing and anti-icing salts and the zinc from tire wear, motor oil, and grease. Transportation MS4 permit language could require monitoring of BMP effectiveness at a minimum number of specific types of facilities, for example, rest areas and maintenance facilities. It could require wet weather monitoring to compare discharges from roadways with and without control measures. It could require monitoring of vegetated filter strips, or it could require baseline monitoring for specific different highway types, so urban, rural, and different geographic areas. We've gone through several examples of permit topics that the transportation MS4 permits might handle differently from other MS4 permits. I highlighted some of the more notable examples, but there are other topics addressed in the compendium as well. For each topic, there's at least one and sometimes many permit language example excerpts to illustrate how some permitting authorities handle the topic. Before we end the presentation part of this webinar, I wanted to show you an actual example of what the excerpts look like in the compendium document. Each example starts with a table showing effective date, permittee name, citation, and link to the permit. As for the citation section, note that citations are to EPA stormwater regulations and are not intended to be a comprehensive listing of possible legal authorities that could support a particular permit condition. Each permit example includes a citation to the relevant provision or provisions of Phase I regulation and Phase II regulation. In addition, the Phase II stormwater regulation includes guidance paragraphs. These are not legally binding, but they can guide permit writers on developing permit conditions. If a guidance paragraph is cited, it is clearly marked as guidance. Below the table with basic information is excerpted language directly quoted from the permit. Note that in some examples, EPA has included surrounding language from the permit to provide context. A note about permit language here. Permits that include specific deadlines for compliance, incorporate clear performance standards, and include measurable targets for implementation enable the permitting authorities to more easily assess compliance. Similarly, they give permittees and the public greater transparency with respect to what actions are necessary to achieve compliance. Phase II MS4 permits are specifically required by regulation to include terms and conditions that are clear, specific, and measurable. I'm now going to end the presentation portion of today's webinar here by pointing out that the US EPA and the National Cooperative Highway Research Program, or NCHRP, have some publications that could also be useful to permit writers working on issuing transportation MS4 permits. I know that web links don't do much good for you right now when you're watching a webinar and you can't click them, but just a reminder that we will be posting a recording of this webinar and we'll also post the slides online soon. And we have a few minutes to field a few questions. Go ahead, Colby.
Thank you so much, Heather. I really appreciate it. This is a friendly reminder for audience members. If you have any questions, feel free to send them in via the questions box, upper right-hand side of your screen, and we'll try to get to as many as possible. The first question we have here, an audience member asked, will EPA require that states incorporate these provisions into their permits? And it looks like, Heather, that's addressed to you.
Okay, thanks, Colby, and thanks for the question. No, so that's the short answer. EPA doesn't require that states incorporate any of these particular provisions. So states are authorized to implement, in general, almost all states are authorized to implement the NPDES program, and so they issue their own stormwater permits with terms and conditions that are appropriate for their own state-specific situation. The compendium we're talking about today serves to provide examples of how permits in various different jurisdictions, so states, and local DOTs how those permits have been tailored considering transportation-specific conditions. But no, EPA would not require any of these particular conditions to be incorporated.
Great, thank you, Heather. Another audience question here, and this looks like it might be directed towards Susan or Heather, depending on who's available to answer. How does the Federal Highway Administration generally support efforts to reduce pollutants in stormwater, and what efforts are underway?
Okay, so I can field this question as well. So the Federal Highway Office of Project Development and Environmental Review has supported various research in this area. So they have been involved with the Center of Excellence of Environmental Excellence Stormwater Community of Practice, which was a panel of state DOT practitioners. That panel discussed what general hot topics were within the states. And so that community of practice actually conceived the development of a national practitioners meeting, which began with, it began a biennial meeting among state DOT stormwater practitioners, AASHTO, and Federal Highway with EPA participation. So that's been a great networking opportunity for state stormwater practitioners at DOTs, so they can have peer exchange and learn from one another about stormwater issues. A couple other things I can mention. So Federal Highways Administration and USGS have worked together to develop SELDM, that's the Stochastic Empirical Loading Dilution Model. And that model can be used to determine the risk of adverse effects of runoff on receiving waters, the potential need for mitigation measures, and the potential effectiveness of such management measures for reducing those risks. So quite a few of the state DOTs are utilizing that model to assist them in interpreting whether their highway projects are contributing to various downstream pollutant levels. And Federal Highway has also published a bunch of reports in the last few years about best management practices, so looking at practices on data collection and performance measurement, and evaluating different kinds of best management practices. Federal Highway also supports the NCHRP, or National Cooperative Highway Research Program, and that annual research program is developed on the basis of research needs that are identified by chief administrators and other staff of the highway and transportation departments, by the committees of AASHTO, and by Federal Highway Administration.
Great, thank you, Heather. Another audience question. Someone asked, you mentioned municipal operations in your discussion about pollution prevention. How are municipal operations regulated under a DOT MS4?
So how are municipal operations regulated under a DOT MS4 permit? Rachel, do you want to provide an answer here?
Sure. Can you hear me okay?
Yeah.
Okay, great. So MS4s do specify minimum elements and require that regulated MS4 owners or operators develop and implement an operation and maintenance program and relate it to municipal operations and good housekeeping. And the regulations talk about good housekeeping for municipal operations. So that's just the regulations tend to use the term municipal, but would apply to transportation departments and other regulated entities under the MS4 program that may not be quote-unquote traditional. And so it is included as part of that. It's just the phrasing of that.
Great, thank you, Rachel. Another audience question. Someone asked, how do you determine if a DOT should be a Phase I or Phase II MS4? And how do you determine the population served to determine small, medium, or large MS4?
Sure. So we talked a little bit about this in the early part of the presentation, the regulatory definitions for Phase I versus Phase II. So it's, pretty technical in terms of the size. So Phase I would be medium and large cities with populations over 100,000, and then Phase II is the small MS4s. In terms of population, that information usually comes from the Census Bureau. So, these are things that are kind of outside of the realm of EPA.
And Heather, can I add to that as well?
Great.
Sure. So DOTs are under the Phase II rule. They're specified as being one of those entities that is regulated there. They can be listed as co-permittees under Phase I. Phase I listed counties that needed MS4 permitting. So in certain instances, because the DOTs were overlapping within those counties, they could be listed as a co-permittee under Phase I permit in addition to having their own separate Phase II.
Great. Thank you, Rachel. Thank you, Heather. Another audience question here. Someone asked a question about applicability. Development of a transportation MS4 is required by state, federal, and county highways other than covered by municipal MS4. Is that the case? And who regulates or issues the permit for the transportation MS4? Would that be the state or the EPA?
I'm gonna turn this one over to Rachel if you wouldn't mind answering this one.
Sure. So the permits are issued by either the authorized state that can authorize the NPDES program, or by EPA. So it depends on which state the permittee would be in, who issues it. But the information, the regulations are identical and applied for both of those instances. I think that was the main part of the question. I know I did see a couple questions related to, and Colby, sorry, I'm stealing your thunder a little, but related to if a DOT is currently covered under a state general permit, could they be pulled out into like a national transportation specific permit? And we can't take back authorizations for the states that have been approved. So like a national level permit is not something that we can do at EPA because it would require us removing authorities that have already been approved. But we can provide information like Heather has walked through today that help share information for specific requirements within a transportation permit.
Great. Thank you, Rachel. And with that, I'm going to turn things over to Heather for closing.
Thanks, Rachel. Thanks, Colby. Thanks to everyone today for joining us to listen. We'll be ending the webinar in a moment, but I want to remind you that it has been recorded, and everyone who registered will be notified when that recording is available online. In the meantime, if you'd like to explore the compendium, the easiest way for you to get there is to just do a quick web search for EPA Transportation Stormwater Permit Compendium, and the first results that come up will get you to a PDF of that document. Finally, if you have any further follow-up questions, please feel free to contact me directly. That's Heather, directly at goss.heather@epa.gov. So thank you again for joining us, and goodbye.